go through the background. We already know that last time we just talked about that if I give you y is equal to f of x, and I also give you a start point, which is on A, and the end point B. So of course, this point will be A, f of A, and this point will be B, f of B, right? So we just think about how to calculate the length following this curve to get the arc length from the point A, f of A to B, f of B. So the idea is still same as the Riemann sum, that we just try to have a partition P from S0 is equal to A, S1, S2, blah blah blah, SK minus 1, SK, then Sn minus 1, Sn, and the endpoint is B. Right, so still follow the Riemann sum's idea that we just try to partition the interval A to B into several sub-intervals. So from S0, S1, blah blah blah, here some specific SK minus 1 to SK, then blah blah blah, right? So especially we just focus on these 2 points. If this point is PK minus 1, and this point is PK. So we try to get the length through this curve, right? If we know how to get this one, of course we can apply the same rule to the rest pieces, right? So let's just focus on this part, that we just enlarge this part to become, okay, here is PK minus 1, and here is PK. Then this is a true curve, right? Right, I just enlarge this part, this portion, to this one. So we want to calculate the arc length from PK minus 1 to PK. So of course, you can see we also have the, if this part is delta SK, so you can imagine that this part is delta SK. So here is delta SK, right? Then we also have delta YK for this portion. So based on this, the estimated will be LK. So we can see LK should be equal to square root of delta SK squared plus delta YK squared, right? We can roughly estimate the length as this one, right? Because this one is easy to get by using this, right? Because this is a right triangle. When we have these 2 slices, then we can have the length LK. So, so according to this LK, we should assume the function is differentiable. So by the mean value theorem, we can find a CK in SK minus 1 to SK. So we can find a CK here. We can find a CK, for example, maybe CK is here. Then with this ck, we can have f prime of ck is equal to delta yk over delta sk. Did you still remember that? By mean value theorem, we can find a point between sk minus 1 to sk. Then we can find a point ck here. Its slope is f prime of ck, right? Its slope will be equal to the slope when you just connect these 2 points together, and you can get the slope as delta yk over delta sk. So we can use this one to replace delta yk. So if so, we can have delta yk is equal to f prime ck times delta sk. Right? So why do we need to do this conversion? Because you can see, if we just follow this one, LK is equal to square root of delta sk squared plus delta yk squared. You can see we need to face two variables. One is x, one is y. But with this, you can see, if we can use this, we can replace this one, delta yk, so that you can see we can just simplify this expression into expression on a delta sk basis. 你可以看到这里呢，如果我们用这种方式做的话呢，它会有个问题，什么问题呢？你会在估算这段长度的时候呢，面临到两个变数的问题。一部分是这个属于 sk 的 s 的变化，另外是 yk 的变化，对不对？所以你会有同时要面对 x 又面对 y 的问题。但是所幸呢，我们有这个 mean value theorem， 我们可以把它怎么换成我可以找到其中某一个点，它的斜率啊，刚好会是等于这两条线的两个点的连线的斜率，还记得吧？这个是平均值定理，对不对？用这个换掉之后呢，它整个式就剩下 delta sk， 这是非常重要的一个改变的点，让你可以换成只剩下面对 s 方向的变化量就可以了。Okay, so with this, we can just convert the original LK is equal to square root of delta sk squared plus delta yk squared. So you can just use f prime of ck times delta sk squared. So then we can continue to do that, and it will be 1 plus f prime ck squared then times delta sk. Because we have delta sk squared, for this item we also have delta sk squared. So we can just move delta sk squared out of the square root. So we can have delta sk. So again, if we want to get the whole L, the L should be equal to limit n is approaching positive infinity, sigma k is from 1 to n LK. Right? I already emphasized the idea several times. This just means that we have an infinite number of subpieces for the whole interval. as the norm p is approaching 0. Norm p is approaching 0. One of the possibility is we just let the number of the subintervals for this interval become infinity. Okay, so based on this, we can get the result will be square root from a to b, integral from a to b square root of 1 plus f of x squared dx. So you also can have a mapping here. Summation is for this one, right? 1 here, 1 here is 1, but as you have infinite numbers of subintervals, that means f of f prime ck will become f of s. Each s point, you can have this one. So you can see here can be mapped here. And then finally, delta sk will become dx. So finally, what you need to memorize is this one. This one. So so based on this idea, we can define if f prime x is continuous on AB, then the arc length of the curve y is equal to f of x from the point A, that means A, f of A, right? To B, B means B, f of B is L is equal to integral from A to B square root 1 plus f prime x squared dx. So we just define the arc length as this one. You can just simply apply the concept of Riemann sum to have this formula. So we can just follow this definition to get the arc length. So we can just quickly have an example to give you some expression about this formula. So for example, if y is equal to 4 times square root of 2 over 3 s to the power of 3 over 2 minus 1, and x is ranging from 0 to 1. So what's the arc length? What's the arc length? So this is the start point A, this is the end point B. So following this, for you, the first step, if you want to solve this problem, you should get the f prime x first, right? So it will be this one. Right? We just simply differentiate the f of x. Then you can get the result will be 4 times square root of 2 over 3 times 3 over 2 times x 1/2. It's another hard, right? Because 3 over 2 minus 1 will be 1/2. Then finally, this is the first step. And then you can get, based on this, you can get f prime x squared is equal to ax. Right? So you already have f prime x here. you already have f prime x squared also here, so that the total length for the arc length from A to B will be formula as L is equal to integral from 0 to 1 square root of 1 plus ax, square root of 1 plus ax dx. And how to continue to get the answer? By using substitution, right? Okay, let me just review the process again, that we just let u is equal to 1 plus 8x. Then immediately calculate this one. That will be 8, so that you can have dx is equal to du over 8. So that you can have the form become square root of u, then times du over 8. Then remember here through this one, that will become how much? 9. Yes, correct. And 0 will become 1. Yes. So you can see, you can just use this definite integral to get the final answer. The final answer will be this one. Maybe I just skip the final part, but yeah, with this form, I think the calculation become simpler. Okay, so let me spend 1 minute to review the whole concept. If I give you a function y is equal to f of x, and I also give you the start point a, f of a, and the endpoint is b, f of b, please just remember this formula. The arc length from A to B will be integral from A to B square root of 1 plus f prime x squared. Okay, but the idea actually just comes from the mean value theorem, to convert from original we have two variables, delta x and delta y, but with the support from the mean value theorem, we can just convert the delta yk, delta y, into delta x, so that you just need to face one variable instead of two variables, x and y simultaneously. Okay, so finally, please just remember this. Okay, so based on this, you can also find a point. If, let me just continue. If dy over dx, that means f prime x fails to exist, please try integral c to d square root of 1 plus dx over dy square dy. So once this f prime x fails, that means you can see when we just calculate this one, we already need to get f prime x ready. Then we try to get f prime x squared. But if this form we cannot have, we fail to get f prime x, how can we do? We just convert it in other angle. So that means, for example, originally it will be, this is x, this is y. So again, supposedly it's still the same. Y is equal to f of x from the start point A to f of a, then to b f of the b, right? This is the original one. So suppose the original, we should get the length is integral from a to b square root of 1 plus f prime x squared ds. But you can see the situation is you fail to get this one, f prime x. So if so, you should find another way. So you can also think about, if we just think about here becomes c, then, oh sorry, we can just convert this one into s is equal to g of y. So y is equal to f of s. Why we have y is equal to f of s? Because originally the question just give you the curve just like this one. But can we just change our angle? When we just see this function, maybe we just from x angle, then we can get y. But can we just slightly convert it into s is equal to blah 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 of gy? So that means y, in this form, we just let x to determine y value. But with this form, we just let y to determine x. Of course, f here and g of s here are, g of y here are different. But you need to find some way to convert it into this one. Then your start point will from c, then this one will be g of c. Then the endpoint will become d. Then the endpoint will be g of d. So with this, with this conversion, the L will become integral from c to d square root of dx over dy square dy. So we just change our viewpoint. Originally, we just view the curve from the x angle, but through the conversion, we can just change the angle from x to y. So of course, your start point, your end point, and also your dx over dy will be also changed. Okay, so let me just give you an example that, for example, y is equal to x over 2 to the power of 2 over 3. If the start point for x is 0, the end point is 2. Of course, when you just find this question, intuitively, you will just follow this rule. So, okay, so we will get this ready, right? If we want to prepare this one, of course we need to get dy over dx first. So if we can calculate it, we can get, you will become this one. Then times 1/2. Then you can see here we can cancel it. Then finally we can get 1/3 x to the over x to the power 1/3. So in this case, you can see dy over dx is not defined at s is equal to 0, because we just, the question just asks as the start point will be s is equal to 0, right? But after we just get the dy over dx, here you can see we cannot let s be 0. So that means we fail to get f prime s when x is equal to 0. So if in such a case, we need to find another way. So originally, y is equal to x over 2 to the power of 3 over 3. Then this is from s angle. Then get y value. So this is y is blah 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 x. We need to find some way to convert it into s is equal to blah 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 y. So the good way is we can let a both side, which is just take its power as x as 3 over 2, then also 3 over 2. So we can continue to convert it to get, you can see here we can cancel it, here we also cancel it. So finally we can get s is equal to 2 times y to the power of 3 over 2. So this is a new form, but even though it's a new form, the equation is still try to describe the same curve. We just change the angle from x to y. You can see with this, we will use y to determine x. Instead, here, we just use x to determine y. Of course, the start point and end point will also be changed, right? So the start point will be when s is equal to 0, then the start point will from 0, that means y is also 0. This case is for s is equal to 0 to y is equal to 1 to 1, because this case is for s is equal to 2. Can you understand that? Original x should be ranging from 0 to 2. Right now, because we just changed our angle from x to y, so we definitely need to find the start point from y angle. So how can we just get y is equal to 0? Because the start point is s is equal to 0, so we just use 0, here, 0. So we can get y also 0. For x is equal to 2, then we just put 2 here. Then we can get 1. So the end point is y is equal to 1. So that the length we can reformulate as integral from 0 to 1 square root 1 plus, okay, here we still need to do one thing, is we need to do this. So this is 2 times 3 over 2 times y to the power of 1/2. Okay, so that will be cancelled it. We can have 3y to the power of 1/2 square, then dy, so that we can have square root integral from 0 to 1 plus 9y dy. Right? So again, when you just find this one, you can just use u to be 1, that u be 1 plus 9y. Use a substitution. Then I will skip this part. Still use substitution. And finally, you can get the result will be 2 over 27, 10 times square root of 10 minus 1. So this part is simple because actually it just want to deliver a concept. If you, in case you cannot get dy over dx, try the other way. The other way is try to get the dx over dy. But before you can get dx over dy, you need to change the form from x angle to the form from the y angle. Okay? And for the rest part, you can see the formula over the same. Okay. Okay. Before we go to the end of this section, I'd like to highlight another idea. If y is equal to f of x and y prime is continuous on AB, then we can just by the fundamental theorem of calculus, we can define a new function, s of x. We define it as integral from the start point a to the end point x, square root of 1 plus epsilon t squared dt. What does it mean? The idea is just like that. Okay, if I give you a function t, y, why would I use t? Because later on I will use x for another purpose. So, of course, here you can see, again, I give you y is equal to f of t, right? So, based on this, if I define it as this one, what the s of x wants to represent. S of x just want to represent the length. For example, a is here. This is f of a, right? And the endpoint x, a is fixed, but the endpoint x is variable, is varying. So, for example, x may be here, s may be here. For example, if this is S1, this is S2. So when you just have, for example, if you just use this one, follow this. If we just use S of S1, what does it mean? It's just I want to calculate this part, right? This is for S of S1, right? If I ask you to calculate S of x2, that means we are talking about from the same starting point, what is the length? Can you understand that? So you can see the endpoint is a variable. If you just put it x1 into this function, we are talking about, we try to get the length from a to s1. If I give you another input s2, that means we are trying to get the length from a f of a to x2 of x f of x2. So you can see by this function we define here is talking about how to make the arc length calculation become a function. 我这边稍微解释一下哈，刚刚那个比较简单，所以我想你应该听得懂。这边大家特别注意一下哈，除了 x 除了 y， 我们又导入一个叫做 s 的变数。哦，平常我们是不是平面上两个轴就是一个 x 轴，一个是 y 轴？那我们现在导入一个变数叫做 s， 这个 s 呢，它所看到的定义就长这个样子。哈，积分从 a 到 x。根号的1加上 f 胖 t 平方 dt， 大家有没有觉得很熟悉这一块？这一块就在算弧长，对不对？弧长里面的起始点到终点，跟刚刚上面的不一样的地方在哪里？上面那一页的时候是，我告诉你一个 a 的起点跟 b 的终点，它都是具体的、固定的。这里所表达的是我的 s of x， 这个是变动的。也就是说，我的起点是 a 是 fixed， 但是我的终点 x 呢是变动。所以我们再看这张图，我带给你的印象应该就更深了。如果我的 endpoint x1， 我把它带 x1 进去，代表什么 ？a 要一直算到 x1 停止的那个弧长。所以我 s of x1 所代表什么？是这个红色的线，从这条线呢。就想象一只蚂蚁沿这条线走，然后走到终点，到这样的长度。如果我把这个 x1 改成 s2， 那我的 s of x2 代表是什么？我想表达是从这个同样的起点之下，但是呢，我想算从这个起点之下呢，到终点是 x2。逗点 f of x2 的长度，所以透过这个定义，先了解这个定义函数这是什么东西。好，先了解这个定义函数，所以这个基本上就是一个弧长的公式，起点是固定的，但是你的终点是改变的，这样了解吗？所以先把这 s 的函数先了解起来。哈 ，OK， so with this, if we just continue to differentiate this function. So right now we already have this, right? And we are trying to differentiate the defined function of s of x. Then you can get, it will become square root of 1 plus f prime x squared. Why? Because we just use the fundamental theorem of calculus. We just integrate this form, then differentiate the outcome. So integrate, then differentiate. Of course, we will go back to the original one, original integrate, right? So it will become this one. So we can continue to convert it as 1 plus dy over dx square. Then if you just treat them as differential, did you remember I told you that dy over dx is not just about differentiation. You also can treat dy, dx to be variables. So of course we can let it become ds square plus dy square over dx square. So if you just convert here to here, actually you just regard dy and dx are differential. That means variable. So okay, with this, we can continue to see here. We can treat it as ds over dx is equal to dx square plus dy square over dx. So if we just treat them, all of them are differentials, then you can see we also can cancel this. Then we can get ds is equal to square root of dx square plus dy square. So then you can treat here is the differential form. Of course, for dx and dy, they are all differentials. So you can also see that actually ds, the concept about ds is, if this is x, this is y, and then every from A to B, you can regard this that here we always can have a small portion for dx. Then we also have a small portion dy, right? As I remember, normally we will use delta x for a little bit large change in x direction, but we use dx to represent a very small change in x direction. So similarly, for y is also, right? We use delta y for a little bit large change in y direction. We also use dy to represent a very, very small change in y direction. So with ds change and dy change, then it will cause a very small change in the arc length. So you even can see here is just line, here is just line dx. Then we have small dx, and we also have small dy. Then this part is ds. You can also regard it as a right triangle. And we, of course, we follow this. We can have dx squared plus dy squared is equal to dx squared, right? So that means the arc length here we want to deliver is, if we want to calculate the arc length, you even can do integral ds, which is summation, small portion for arc length and summation. So actually, I hope you can understand the concept, but if not, later on when we just talk about the how to get the surface by revolving the curve, we will also talk about this idea. But I want to just keep this in mind that we not just have dx for x direction, dy for y direction for very small change, but we also have ds to represent a very small change by following the arc length. 这边呢，大家如果听得进去最好啊，听不进去也没关系。等一下我们再讲旋转表面积，我们在这一块会再稍微提一下。但是这边哈，要让大家知道，过去我们在做这种differential 的时候，我们常常讲这个 dx 啊 dy 啊，我们所讲的都是一个是 x 轴上面的微小的变化，一个是讲是 y 方向的微小变化，我们都用 dx 跟 dy 来代表嘛。所以相较于我们有 dx 跟 dy 之前，我们有什么 delta x？ 还记不记得我们前面讲的这些？当有很大的变化的时候，我们会用 delta 这个三角形 ，for s 方向的变化叫 delta x，for y 方向叫 delta y， 对不对？但是随着这个切割越切越细，细到接近零，非常非常细微的小的时候呢，这个变数就会变成 dx， 这个就变成 dy。我们讲的是在 s 方向很微小的变化 ，dy 讲是在 y 方向很小的变化。那我们这边呢，要特别导入一个这个 ds 的概念，好，刚刚已经 帮大家推导到这里了，这个我想你应该有清楚了哈。S 是一个弧长公式，起点固定，终点变动的。好，所以呢，如果它是一个公式，那我们当然可以对它做一个微分，对。所以推导出来，你会发现这个 ds 会等于根号的 dx 平方加上 dy 平方开根号。那这个有没有觉得很刚好？就是如果我们在讲直角三角形的时候，两边的平方和开根号刚好会是平这个 ds， 对不对？所以这件事情就告诉我们说，其实我们在定义这个 S 是这样的情况之下呢，它的微小的变化量在弧长沿着这个弧线，沿着这个曲线走的变化量刚好恰巧等于根号 ds 平方加上 dy 平方的斜边。所以这件事也呼应了什么？我们一开始的时候在估算这个的时候有没有？你把它放大到很大的时候，当然你会发现这个黄色的线其实跟这个绿色线误差还挺大的，对不对？但是随着你的 delta x 跟 delta y 越来越小，说到很小的时候，你会发现其实这个绿色跟这个黄色的线段长度啊，其实叠在一起。所以后面那个要证明讲的是什么？其实到最后，虽然你一开始是放的这么大，它估算出来会有一个误差。可当你说到很小的时候，你的 dx 的平方加上 dy 的平方就会等于这个 ds 的平方。好，所以呢，最后呢，如果你可以知道这 s 的话呢，事实上你要算它这总积分的弧长的话呢，事实上你是在算 ds 的积分。ds 的积分就会得到你这总弧长，哦，那这是导入一个 s 的概念。其实这个在后面，其实在某一个章节在讲这个的时候，他会特别去讨论这个。但是因为后来因为那部分我们有跳过去，但是起码至少让大家在推导这个时候哈，知道有这个关系啦，知道有这个关系 S 跟 X 跟 Y 有这样的一个关系哈。Okay, so we almost finished the section 3. So maybe I just note it down, the question list here. So this part is just talking about how to use integral to calculate the arclength. Especially I give you a start point and an end point. And here we also talk about if you cannot solve the question with respect to x, why not just change your angle from x to y? Then you can also get the answer. And here we just talk about the additional one variable s, and also describe the relationship between ds with dx and dy. Oh, okay. So maybe let's just stop here for a while and then just come back to the classroom 10 minutes later. Then we will talk about how to revolving one curve, then get the area of a surface correspondingly. So this is the area we are talking about, the area of surface of revolution. So I believe you already know what a revolution is, right? So the so-called revolution is I just give you a function, and then I also give you the axis of revolution. Then you just use the curve and revolve the curve following the axis of the revolution, then you can get the solid, right? So in section 2, we are talking about the volume, but this time we are talking about how to get the surface. Okay, so then There are two ways to define the service area. So the one way is, there are two ways, and one and two is, one is a cylindrical surface. The second one is a conical surface. So let me just tell you what's the difference. What's the difference? So for the cylindrical surface is just like this x, y. So we also have two. We have these two ones, but for y is equal to f of s, when you just use the cylindrical surface, the result will be different from this one. If you just adapt for the conical surface. So for the cylindrical surface, it's just like, okay, you still follow the Riemann sum idea. From A to B, you have a start point A, start end point B. For cylindrical surface is, okay, you continue to partition it for several parts, especially we just focus on sk minus 1 to sk, right? Here also sk minus 1 sk. But the only difference is, you can see if I just use this to revolve the surface, right? I can use sk minus 1 to revolve. I also use sk by using its height to revolve, but I use the delta sk to, here is delta sk to become its width. So you can think about that. If I want to get the surface, you know, the surface suppose it should be here, right? This time we are not talking about the volume. We are talking about the surface of a revolution. So if you want to get the area, we can just cut it. Again, we can, suppose we need to calculate this one, right? But we can cut it, then just write it on the plane. Then we can get, it should be like this one. But we just use delta sk as its width. And this part will be 2 pi y. Y means the height. Y means the height. So the size will be s is equal to 2 pi y times delta x, right? Because the length, when we just divide it, we can get 2 pi y times delta x. Then that means we just use delta x as its width. But if you just use cylindrical conic surface, that means it's just based on the cone. So if so, the idea is, for example, here is y1, here is y2. So again, we also just revolve it and also revolve it. But the difference is we just use the delta s as its rough width, and especially we also take the average y star as the average of y1 and y2. So the same idea also applied to calculating the surface. So this time we use delta S as a width, and we use y star here by using 2 pi y star. So you can notice that y star here and y here is different, but when the partition becomes very, very small, actually y will be the same one. Even though we just had the average, actually when the small portion becomes very, very small, it will become y only. But based on these two ideas, that will be S is equal to 2 pi y star delta S. And basically, make it become smaller so you can have a simple comparison. Y and y star, actually when you become very small, they will become the same. But the only problem is use delta X and delta S will be different. So that's why I just want to introduce S variable. Did you still remember? That's why I just introduced S variable to you. S is about the arc length, but X is about the difference in X direction. But finally, we will choose this one. We will pick this one as the estimated area for the surface of revolution, and normally we will call it as Frosten. In Chinese, it will be 平结头体。凭借头体就是有没有？我们如果你们学生喜欢在庆生会的时候，不是每个人会戴那种尖尖的那种帽子，有没有？把它截掉。凭借头体 means, for example, just like okay, like this. Then you just cut it. You just cut it. Then you can see only the shape will just depth here, and this is the Frosten. This is the Frosten. So you can see, following the Frosten idea, here you just think about this part is just equal to 2. But for the cylindrical surface, it will become always circle. Always circle. It's just a can. But the conical surface is just follow the cone. The cone. Okay, but we just follow this one. And maybe I don't have time to explain the detail, but in our textbook, they also try to prove following this will fit the same result by in the traditional geometric calculation， 就是说在传统的古典的这个几何的计算来讲呢，这个算出来会跟我们的传统的几何的做出来的这个表面积事实上一样的所以如果有时间呢，可以多花点时间去看一下。但是 anyway， 最后我们就 follow 这样的一个想法特别是课本有举了一个例子，就是当我们在算那个圆锥的 面积，不知道大家有没有背那个圆锥的面积？就角这个圆锥的面积，这个圆锥的面积的时候，事实上你如果用积分的角度，用平截头体算出来的结果，会跟我们用传统几何的角度去解它的答案会是一模一样的哈。所以后来我们就是采用这个哈。Okay, so if you accept the basic idea, then we start to use the Frost-Run service to calculate the service of a revolution. So the idea is just like this is x, this is y, and we have y is equal to f of x. So we have x here, a here, we have b here. So we also have some partition from s0, s1, but here one special point we will have sk minus 1 and sk, then sn minus 1, and then finally sn, right? So we just focus on these two ones, right? So use this, we can get the service will be like this one, and this part will contribute this one, right? So you can see here, then that's because the axis of a revolution is x, so we just rotate the service by following the axis of a revolution as x-axis. Of course, you can also use y-axis as its axis of a revolution, but normally we just use the axis of revolution as x for your reference first. So if we want to follow the Frost-Run service area, that will become 2 pi times f of s k minus 1 plus f of sk divided by 2. That means we just try to get the average, right? As I show you, I just use the average as its high to revolve times square root of delta sk square plus delta yk square, right? While we have this part, we are just talking about this part. So this part is also like we just mentioned in the previous session. We have delta sk, we have delta yk, but here we try to get L of sk, LK. But the true curve is just like this, right? Even though when we just enlarge this small portion, you will see there still have some difference from the true curve and the estimated curve, right? So if we already know how to calculate this part, this part, so this part we are talking about, we try to use this one to get. So finally, if we want to get all of the services and then sum them together, we can get is almost equal to this one. Times this one. But this time we already know this part can be converted as f prime ck square delta sk square, right? By using the mean value theorem, right? We can just replace delta yk as delta sk, so that for the whole equation, we can just focus on delta sk instead focusing on delta sk and also delta yk at the same time. So we can just use the mean value theorem, just like previous one, so that the final estimation could be like sigma k is from 1 to n 2 pi f of sk minus 1 plus f of sk, then divided by 2 times delta. We can just get 1 plus f prime ck square delta sk, because we can use this conversion to get this one. Then again, as the norm p is approaching 0 or n is approaching positive infinity, the result a should be integral from a to b 2 pi f of x times 1 plus f prime x squared dx. So please also just have a mapping. Summation here will be mapped to the integral, right? 2 pi still here, constant, right? For this part, become 1 f of s, because you know, if the portion, as the norm p is equal to 0, that means each point could be a very small subinterval. So at that time, f of x minus 1 will be equal to f of x, f of sk. So this one f of x, we have another f of x, 2 f of x divided by 2, so that you can get 1 f of x. So here we can get this one. Then here you can see have a mapping. So each ck will convert it as x, become all point, each point will be represent ck. Then finally we have delta sk to be dx. So please just bear this in your mind. Integral from a to b 2 pi f of x times square root of 1 plus f prime x squared dx. So you can see there is a little little difference for the area of the surface of a revolution. You can see this formula is just like this, but if we want to calculate the length, arc length, it will be this one. So actually for this part, the same, but this is about the arc length. But if we just add 2 pi of x, that will become a revolution. That will talk about the area of the surface of revolution. So they are different. One is for, this part is for length, but this part is for the surface. 公式看起来有点很像哈，但是这两个的用途完全不一样哈。这个你会看起来它有2派的 f of x 乘以这个哈。那为什么我这个都要稍微再讲一次？这个原因就是，万一你公式忘的时候，你自己稍微 推导一下，你就会把这公式记起来。一次忘，一次推，一次忘，一次推。我相信3次之后你就背下来了，了解吗？所以这个但这个是要算的是面积，是2π f(x) 乘以根号1加 f'(x) 的平方。这个呢，算的是弧长，是长度单位是长度单位，千万不要搞混了这是根号1加 f sorry。Here should be f'(x). Okay, so I can give you an example that, for example, if we are trying to calculate the surface of a sphere, y is equal to square root of a squared minus s squared. This is minus a, this is positive a. So we calculated this before. This time we just talk about the volume of a sphere. But this is last time. But this time we are talking about the surface of a sphere. This time we focus on volume, this time we focus on surface. So again, after you just revolving the curve by following the x-axis, then you can get a ball. Actually, you can get the ball. But this is a sphere. But this time we focus on the whole volume, the solid. But this time we just care about the surface of the sphere. 上次讲的是一个球的体积，篮球的体积，但这次谈的是篮球的这个表面积但是还是用旋转的方式去产生出来的Okay, so next time we also talk about this, right? Okay, so if so, remember we need to prepare f of x, and we also need to prepare f'(x) squared. So the first step for us is we need to get f'(s). So that means we are trying to differentiate a squared minus s squared 1/2, right? So it will be 1/2 times a squared minus s squared times to the power of negative 1/2 times negative 2x. So then if we already have this, then we can have 1 plus f'(x) squared as 1 plus this one, right? 1/2 a squared minus s squared negative to the power of negative 1/2, right? Maybe at this moment you will see it's a little bit complicated, but at least you just prepare f'(x) first, then try to prepare 1 plus f'(x) squared after. So with this, we can continue to simplify it to be 1 plus, okay, so this is the square, so it will be 1/4 times a squared minus s squared negative 1 to the power of negative 1, then 4 s square. Any problem from here? Square. So for one help, it will be 1/4. For this quotient, we will have 2 times negative 1 half, so we can negative 1. For this quotient, we can have 4 times s squared. Okay, so let's just continue to reduce it. Then it will be 1 plus, here we can cancel it. Then we can have s squared over a squared minus s squared. So that we can continue to reduce it as a squared minus s squared, a squared minus s squared plus s squared. So we can cancel these 2 terms. So finally, we will have a squared over a squared minus s squared left. So the surface will be integrate from negative a to positive a, 2 pi what? 2 pi f of s. So it will be square root of s squared. A squared minus s squared times this one, a squared over a squared minus a squared. Then, we forgot we need to take the square root. Not just put it here, but also we still have a square root, so that you can see here the same term, we can cancel it. And finally, we can have 2 pi a ds. So it will be 2 pi ax from negative a to positive a, and then finally that will be this one. Let me just let it become smaller so you can have an overall picture for this part.
好，这种题目其实没有什么特别的就是要把一步一步把那个我先把公式稍微拉一下。
公式在这里，公式在这上面稍微被卡到，
没关系因为记得旋转的表面积呢，公式从 a 到 b 2派 f of x 乘以根号1加 h' x 平方对 x 积分。所以当你要算球的表面积的时候，第一个你要先把什么 f of x 给确立出来，对不对？所以我们是利用什么球圆的这个上半圆，你用下半圆可以的你用左半圆、右半圆都可以，但是这个式子会变得不一样。好，那就把这个函数确立出来，同时要确定什么 a 到 b， 那刚好球的部分刚好是从负 a 到正 a， 因为它是一个对称体，对不对？好，那接下来要做的是什么？就是一些冗长的计算，这计算包含什么？你要先把 你已经确定 f of x 对不对？还不够，你要什么 f' x 的平方加1和开根号，所以就一步一步来，先算 f' x。但是我用出来，这个大家应该不会太难才对，只是看起来会不太好看，但是就是照着做就对了那接下来有了 f' x 之后，就把平方再加1，去做一些整理。整理出来之后呢，它会得到 a 平方除以 a 平方减下 x 平方，就最后这个。然后最后有的时候全部套进来，我少写了 dx 没关系，我再补上去2派，这是 f of x， 这是1加上，不要忘了，这是1加上 f(x) 的平方，开根号，要开根号，所以最后 dx，
我少写一个 dx， 然后做这样的积分，积分出来的话，就是大家应该以前有背过，球的体积是多少？4派 r 3次方，对不对？球的表面积呢是4派 r 平方，这 r 是半径的意思啊。OK， 好，如果没有问题呢，我们就继续。Okay, so this is this is about the surface area for the revolution. So right now I want to define surface area for revolution about two types. One is y-axis, the other one is x-axis. Because you know, we cannot just revolve the curve by following the axis of the x-axis, but also maybe possibly I just ask you to revolve the curve by using y-axis as the axis of a revolution, right? So there are two types. If just revolving about y-axis, and one is the revolving revolution about y-axis, and then the other one is revolution about x-axis. So if f of x is continuous, continuous, it's the differentiable on AB, the area of the surface generated by revolving this curve. The curve y is equal to f of x about x-axis. The result will equal to integral from a to b 2 pi y square root of 1 plus dy over dx square dx. And some symbols you need to notice that since this is revolving by using x-axis is axis of revolution, so here will be y, and here will be dy over dx, right? And also here will be AB, right? AB is here. This is for revolving by x-axis. But if I give you, for example, in this case, you will be giving y is equal to blah 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 of x. Then you will get this one. But if I ask you to get the surface area of a revolution about y-axis, that means I will give you s is equal to blah 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 g of y. So actually the whole formula is almost the same, but only difference is here. Maybe here will be C to D. Then I will give you S is equal to G of Y. But the axis of a revolution is Y is equal to Y axis. So in this case, it will become, the formula will become integral C to D 2 pi. Remember, here should be X. Square root of 1 plus ds over dy square, then dy. So in this case, if you are given s is equal to blah 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 y, you will follow this. Then I will give you this one, and the axis of revolution is y-axis, and the range, the interval will be c to d instead of a to b. So actually they are the same, but only difference is, please just keep this in mind, that if your revolution, your axis of revolution is x-axis, x-axis here will be 1. If y-axis here will be x. Let me just emphasize x here. Here will be x. Okay, let me just give you a quick example for this part. For example, if s and y, I just give you this, s plus y is 1, but the revolution is y-axis. Okay, remember, if the revolution is y-axis, you need to change the function, become s is equal to blah 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 y. So it will be 1 minus x, 1 minus y. If the revolution is here, that means you need to change it into y is equal to blah 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 x, then it will be 1 minus x. Okay? So different axis of revolution, the function you face will be different. Let me just emphasize again. If the revolution is about y-axis, you need to change it as x is equal to blah 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 1. If the revolution is about the x-axis, you need to change it as y is equal to blah 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 x. Okay, but in this case, we just follow this one. So the s will be, here is 0, 0 is 1, integral from 0 to 1, 2 pi. As I told you, if the revolution axis is y, we will follow this one, 2 pi x times square root of 1 plus dx dy square, then dy. So it will be integral from 0 to 1, 2 pi y, s will become 1 minus y, right? Because we already have this, right? So this, then we can have this, then square root of 1 plus, here will be minus 1 square dy. Then the result will be 2 pi 1 minus y square root of 2 dy So finally, the result is quite simple because the integrand is simple. The result is square root of 2 pi. This is the result. And okay, maybe I can just give you can just think about that. The final result will, the shape will be look like this one. So we are talking about how to get the surface, right? So actually, if we just follow the traditional geometric theorem, that actually the shape here will be, this is S, and the whole circle here is 2 pi r, and the surface will be, the whole surface A will be 1/2 times 2 pi r times S. If we just follow the traditional geometric theory, we can get it. How we can get this one? Just think about it. You just use a scissor to cut, then roll it as plane, then you can get, it will just lie this one, and then cut. You just roll out. This is the center. So here will be S, and here will be the angle theta. So if you want to get the theta, it will become to 2 pi r over S by the fan area,
right? 2 pi rs.
Then if you want to get the A, the whole A will be theta over 2 pi times S squared pi.
Because for the whole circle, we can get s squared pi, but we just get portion. We just get it portion.
So based on this, you can get 2 pi r over S over 2 pi times S squared pi. So finally we can get rs pi, then we can get this one. So we just prove it actually why we can get the formula
1/2 2 pi r times s.
因为这边呢，我很快就讲一下，怕你们可能太快，你们听。你们以前如果有学过这个锥形体的表面积的时候，老师如果有学过了哈，老师应该有教你们背说斜边去乘以这个圆周，这个背过吗？可能没有哈，没关系。那刚好这个时候就告诉你们了哈，这个表面积是这个，它的表面积是这个。那我下面这边只要证明说为什么它是这个圆周去乘以这个斜边呢？怎么来的？很简单，
你把这个截开来，用剪刀把它剪开来，把它压平。压平之后，你会发现这个斜边呢，是就是它的大圆的圆半径，但是它不会是一个完整的圆，它只会占着西塔角，对不对？如果我知道整个大圆是 s 平方派，那我如果知道这个西塔角的话，我可以知道它跟2派之间的比例关系，计算出它的面积，对不对？那这个角度怎么来呢？这个角度就变成它这是一个扇形嘛，大家知道扇形的这个弧长，扇形的弧长会等于半径去乘角度嘛，所以你的角度就会等于 除长一除半径，所以你就用这个把它带进来，所以最后的结果就得到这个。好，那今天也许聊不及讲，不过你可以看得出来，如果你用刚刚这个例子来套它的 R， 以这个例子来讲，哦，它的 R 是1，它的 S 是根号2，所以它的面积呢是等于1乘以根号2乘以派。这部分是补充的，所以你不一定能了解最好，不了解没关系，它是根号2派，跟这完全吻合。有没有发现？我用积分算出来，根号2派。我用传统的几何学去解出来是根号2派。哦，所以这个让大家理解一下，但没关系，这不强求，这部分其实是额外补充给大家，真正要大家了解背下来是这个。哦，好，那我们今天就先到这里啊。哦，
要开2杯，2杯只会送1，他6杯会送1次，再送1次是吧？要是的，一种是6杯，6杯送1次，就是送一些饮料，一些简单的那种，啊，然后就是